Okay, today I plan to do Leetcode contest 281 from last Saturday. So I'll do this virtually. I didn't do it last Saturday, so here goes. All right, time to shine. Open these up. Okay, here we go. Count integers with even digit sum. Strings with num, they're even. Only integers less than or equal to 4, whose digit sums are even, are 2 and 4. 14 integers are less than or equal to 30, whose digit sums are even. What is this, 15? Positive, the digit sum of a positive integer is the sum of all of its digits. Okay, so 1 plus 5 is. Okay, so there's 1,000. Okie dokie, let's do this. X, okay, so for, let me just call this thing our target. Yeah. For X in range 2 to T plus 1, non-inclusive, so some 2 to T. Digits of X, okay, let's see. F equals lambda X, and it'll return true if the sum of the digits is even. So let's do continually delete the last value def okay X, so while X divided by equals 10, and then X modulus 10 will add on to total X modulus 10, and then we'll return T modulus 2 is 0. That one's okay. If okay X, then do this count plus equals int okay X, return count. Something like that. 2, 14 looks good. Okay, that's legit. And another way we can do this is consider X functionally. That's what I was originally thinking. Let's do this. Okay equals lambda X, and then we'll do for C and strx. We'll want to change that character into integer, list of characters into integers, and then we'll do sum of int C for C and strx sum. Let's do this, not sum and 1. Oops. That's okay. So I don't know, this looks a little bit nicer maybe. Let's do sum minus 2 equals 0. So it makes it okay. I don't know. I mean, it's okay solution, right? Nothing too fancy, nothing to get hung up on. Let's do this. Start threshold. Auto okay equals. Write that next. So for auto x2, x is less than or equal to t. If okay x, let's count. I'm going to return the count. Count to 0, and then okay is while x divided by equals 10. And then we'll have our total t plus equals x equals 10. Turn dot t and 1. Okie dokie, looks good. All right. Let's just code this real quick in the other languages. Keep going. Python 3. Ooh, I'll do Rust too. Might as well. It's good practice. A new language that I'm still learning. JavaScript. And then I'll do Kotlin too. Okay. Grab this guy. Seems cool. Stick that there. All right, let's do JavaScript. Count is what we'll return. All right, and then let's do let OK equals X. X dot to string dot split dot map each character into a number, right? C dot char code at 0 minus 0 dot char at 0. And then we'll take the sum of this and ensure that it is even. Oops. Okay, for let x equals 2, x is less than or equal to t, if okay x, count, already, looks good, yay. Okay, there's JavaScript. All right, Kotlin, and then I'll do Rest. Let's get to it, come on. T, count is 0, which will return. And then our OK equals integer dot, let's do this. X is a string dot to char array, which we can map dot to int minus 0 dot to int, and then take the sum of this and return true if it's 0. And then for x in 2 until t inclusive, if okay x, increment the count. There we go. Okay, that looks legit. Okay, now it's time to do Rust. Rust will be the tricky one. That mute count goes 0. Turn the count at the end. And then for x in 2 until t inclusive, if okay x count plus equals 1, then fn okay x I32, and it will return Boolean t equals 0, return t modulus 2 is equal to 0. While x exceeds 0, divided by equal 10, total plus equals x modulus 10. Okay, let's see what happens here. Cannot assign to immutable. Okay, let's mute x. There we go. That looks legit. Yay. Okay, let's post this and go on to Q2. All right, a few solutions. Consider each candidate x from 2 to t inclusive, where t is the input target value. Yeah, that was good, right? Something like that. Nothing too fancy. Okay, cool. So done with that one. Merge nodes in between zeros. So you're given the head of a linked list, which contains a series of integers, separated zeros. Beginning and end will have node value 0. For 2 consecutive zeros, merge all nodes lying between them into a single node whose value is the sum of all the merged nodes. The modified list should not contain any zeros in between these two. So 4, 11. Okay, that makes sense. Then we'll just do a linear scan and then keep the sum, right? Nothing too fancy. I want to keep track of how long this takes me, though. I forgot to keep track of this one. Okay, 618. And let's go. Okay. So while head equals head.next. And then answer equals this. Return the answer. And then we'll have a current window. Current in between zeros. So we need a beginning 0 and an end 0. I should be able to just keep that with a bit, right? Start, end. I guess the end of here is a new start of another one. So how am I going to keep track of the zeros then? So whenever it reaches 0, if there's something in current, push it to the answer. If not, head.val. And the length of the cur. We'll push cur and start append copy of cur, and then cur is cleared out. Otherwise, we'll just push it on the answer or the current, right? Cur.append, head.val, head.next. Okay, that looks legit. Uh-oh. List node, answer, not a valued value. Oh, I need to take the sum of those, right? Okay. Sum of current. List node. Oh, it's a list node. It's not. Okay, I see. Okay, so answer.append list node is a value. Okay, I see. Now answer is not an array, it's actually a linked list. So answer can be a sentinel value then. Sentinel current. So we need a current sum and we need a current answer as well. List nodes, -1. Okay, so we'll turn sentinel.next. And then a current answer. Current will be this is total. Will be a current sum. Let's see. Read and write maybe. Write equals sentinel. Read and write head sentinel. T was 0. Okay, that works, right? Read. So how am I going to keep track of the current total then? Okay, it's 0 and we have a total, then we want to do write dot next equals new. Oh wait, hold on, not new, list node. So the value of t equals 0, and then write equals write dot next. Write equals write dot next. Otherwise, t plus equals read dot val. Read equals read dot next. Sentinel dot next. Right equals write dot next. Okay, I think that looks right. 4 and 11. 1, 3, 4 should be the other one. Looks legit. Uh-oh, it's taking a while. Okay, here we go. I was gonna see Leah. Oh no. Okay, 6:25. Okay, that's about 7 minutes. Okay, cool. And that's pretty legit, right? Read from this right to that, and then we have a signal. Cool, good enough. All right, 6:25. So we'll start here. Let's fill in the rest of these, and we'll do read, write. I guess maybe I just call this thing read, huh? Read. Write equals sentinel. This T we can stick up here too. T is our ongoing total, which is accumulated. And that's a little bit cleaner, right? It's kind of cool. Okay. Takes a while, taking a while. Okay, it's cool. It's legit. The OJ says, yay. Read, okay, and list node. Yeah, I wish Leetcode had smart pointers instead of raw pointers. He's kind of silly, but all right, whatever. Sentinel, N-T-I-N-E-L equals new list node. Return sentinel. Next is the answer, and then this will be the right. Right equals No. All right, so while read equals read next, and then we need our total t equals 0 if read to value, right, 0 and t, then 0.t, we'll push that onto the answer. So write sub next, new list node, t, right equals right sub next, and t equals 0. Yeah, 0.t here maybe. I mean, that looks kind of, wait, hold on. And then we have to do the else part, right? Else. Yeah, else t plus equals read sub val. It's not equals equals but equals. Okay, that looks good. Oh, no viable conversion. Nope, that's right. Star over here. Uh-oh, that's not right. 132. I'm getting 134 is what I expect. 1, 2. Okay, something's not right here. Read equals read that next. I'll read. T plus equals read that value. If it's 0 and there is a t, then we'll push the t onto right. I just write that next. Sentinel next. What the heck? How does it equal to 1? Let's output it, I guess. Value. Reads value, and then total t. What's going on? How's the total 0? Value's 3. Oh, t plus equals. Okay, that looks legit. Okay, minor typo. Accumulated in the total. Yay. Okay, 625 to 629. 4 minutes. Okay, let's do this in the other languages. Then move on to the third question. All right, let's do this. Come on. JavaScript. Oop. All right, we'll do Kotlin. Okay, let's get to it. Let's see this guy. I'll grab. JavaScript. Okay, 6:30. All right, let's go. Time to shine. All right, got read and t0. Then we'll do Sentinel equals new list node. Turn Sentinel next. And then right equals Sentinel. All right, while read next. Then if read.val 0, t is not 0. Otherwise, t plus equals read.val. And then to write.next equals new node t, 0 t, right equals right equals right dot next equals, that's kind of cool like that maybe. All right, then we don't need these things. Looks legit. All right, 6:30 to 6:31, about 1 minute. 1 minute. Okay, that's cool. All right, coming for you, Kotlin. I'm coming for you. All right, 6:32. All right, here we go. Time to shine. Read cannot be undone though, right? Because I have to do it like this. Read right equals pair. Read underscore, and then right will be a sentinel value. Sentinel list node 1. Sentinel return sentinel. Next. All right. Let's do it like this, a little shorter. Okay. So while read does not equal null, read equals read next. Okay, and then if read val equals 0. Hey, Leetcode, could you maybe change this to not be a keyword? The backticks are extremely ugly. T plus equals read val. Do this. Okay, and then right next equals list nodes of t equals 0. Right equals right dot next. All right, let's see what happens. Unresolved reference t. Oops, I didn't make t. 0. Right. Expressive and loud. Oh, okay. All right. Right equals right. Next. Okay, it looks good. 6:32, 6:34, about 2 minutes. Okay, and now saving the best for last will be Rust. Do this in Rust and then move on. Okay, Rust. Yeah, Rust is scary looking. Let mute, read, mute, write. Let mute sentinel equals list node inside of a box. Ay, ay, ay. Yeah, I'm not too familiar with the Rust, so this is going to be a painful experience, I think. Not sure exactly what I'm doing here. Okay, so what I want is new, like I want list node, new. Okay, there's my sentinel, read and write. So I want to destructure head. And then sentinel. Sentinel. These are mutable. While read does not equal null. Read equals read. Next. If read.val is not 0 and let mute t equals 0, t does not equal 0. Otherwise, t plus equals read.value. Right dot next equals list node new total, and then t equals 0. Right equals right dot next. Okay, something like that. Cannot find null. Wow. Some read? Does that work? I don't know. Some read does not equal none. I don't know. I think that works okay. No field val on type box. Expected enum option pound list node. What? Expected to this type of binding. Okay, I'm gonna come in back and do this because I basically have to like look this up and figure it out to do implement me. That's good enough for now. Whatever. We'll come back. It's good to know. I'm not very familiar with the boxing, the unboxing, and all that stuff, and the rest. The reference counter variables, automatic reference counter variables, still kind of unknown to me. So work in progress. A few solutions. Oop, a few solutions, plural. I guess, I don't know. Let's do this. Might as well write a little description, right? Perform a linear scan of the linked lists, accumulating total of the node values between 0 accumulated total T of consecutive node values in between nodes with value 0. Right, okay. Perform a linear scan of linked list, accumulating each total T of consecutive node values in between nodes with value 0. Right. And then we read and write. Those are pretty straightforward. Rest I'll do later. Good enough. Okay, let's move forward. I'll come back to this one. Do in Rust. Do this next. Okay. How much time do we have left? 56 minutes. Okay. Q3. Here we go. Actually, let me get some coffee. I'll be right back. Okay, I'm back. My music going here. Okay. You're given a string S, an integer repeat limit. Construct a new string, repeat limited string. Using the characters of S so no letter appears more than repeat limit times in a row. Now to use all the characters of S. Return lexicographically largest repeat limited string possible. The string A is lexicographically larger, blah, 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 blah. Yeah, I know what a lexicographic order is. Alphabetical order makes sense to me. The character is not different though than the longer string is lecture. Okay, that makes sense too. Right. Repeat limit. So we use all the characters as to construct. There is no repeat limit that exceeds 3. Repeat limit is 2. In a row. What is wrong with? Oh, okay. Lexicographically larger. Okay, we want the biggest one. That's why we order these differently. Biggest first. Okay, so we should be able to use a map and then greedily construct it, right? I think that makes sense. So here's the game plan. Probably should have started my timer, 6:42 a.m. All right, so the game plan here is to use a map to count the frequency, right, frequency of each character C of the input string S, right? And then greedily consume the map in reverse lexicographical order at most k repeat limit consecutive characters is allowed. All right, thus we need to interleave the most frequent with the second most frequent. Wait, no. Interleave the graphically larger, right? Interleave the graphically largest with second largest, right? Something like that. Okay, let's say K be our repeat limits for the S. Actually, let's do counter, right? M equals counter S. Okay, and then second largest and largest. Can we just do first and second? It's 10 to the fifth, so we need the linear algorithm. All right, so n equals 25. Yes, we are looking for a linear runtime. Runtime to avoid TLE. So M is our counter of characters. The answer will be something that we can construct. T will be the string we construct from S, and then we can return, to turn T into a string. Okay, so how do I efficiently do this, right? The question is how to efficiently enter leave values available in the map. But there are only 26 characters. May I just go through all of them? See, okay, here's the first lexicographically best, and then use it up. Let's just do this, okay. For each character, C and Z down to A inclusive. So what we'll do with each character is find the next character, right? For each character, D and C minus 1. Let's find first D and M. Here we want to do find first C and M. Okay, and then after we do that, then we can consume up to K instances of C to the answer. Consume one instance of D to the answer. Right, and then repeat. For each character, C and Z down to A. Find the first character. That works, right? Okay, let's code it and see what happens. Or C in range. Do we use the ASCII ordinal values or? I don't know if this will work or not. Z down to A minus 1 non-inclusive. I need the 1. I don't know if this will work or not. It should print Z through A. Yeah, that's what I was thinking. That's not going to work. Okay, so we do need the ASCII ordinal values. 122 down to 97 non-inclusive. Each ordinal value, right? This is ordinal. char from CHR from X. Yeah. Okay, that's what I want. Take up to K of these things. If, let's see, character equals CHRX, if C and M, then we can consume one, right? If C is not an M, then we will continue. Otherwise, if C is an M, then we'll consume it. To K of them. I'll take it's less than K. and m sub c. Append the character c onto t, which our answer. Increment take, then that equals 1. If not m sub c, then del m sub c. Okay, so we take up to k of these things, and then we'll take one. Next one, if it is equal to k, the next one, so if take is equal to k and there's some more left of this thing, that's the only time we have to interleave something else in between it, which is the second best, right? So for y in range x minus 1 and the 97 minus 1. If d not in m, continue. Otherwise, we'll take one of them. And that one that we take, we'll have to count for the next iteration as well, right? Wait, no, we don't. Okay, that should be okay. Take equals k, the next one we can take, and there's still one left over. Then we have to interleave this single d, t dot append d. D m sub d minus equals 1. If not m sub d, then I'll delete it. Okay, so from z to a, if it's not on the map, we continue. Otherwise, we'll take up to k of these things. We took all k, and we still have one left over. We must interleave. Take one of these things for m sub d. If there is no d and there's only m sub c, take those 0 if the t and t sub -1 is not equal character. it as is. So if we have taken all of them, and there still exists one, but we cannot interleave another one, then we want take to equal itself rather than 0 here. Right? And there's just a weird use case. ZZCCCA? Z, there's 2 Z's. For some reason I have 3. Wait, is that look right? No, there's CC. Does that look right? No, that's not right. Yeah, so it's just kind of a tricky use case. It should be this, right? Okay. Another C that I can add onto it. A, and then a C. Oh, looks like graphically bigger. Okay, so let's do this in 122. 1, 2, 3, 4. Okay, too many C's in a row. See how much time I have left at 37 minutes. This one's taken 18 minutes so far. Like, hey, caramba. Okay, it's taken a while longer than I'd hoped. And it's still not even a correct answer. Oops. How do we know to pin that last C on there? I think this is one that's not necessarily algorithmically complex, but it is kind of difficult to code properly because of all the weird use cases. So remember to keep it simple, keep it super simple, right? KSS, keep it super simple. Otherwise, I'm going to mess it up. Okay. So how do I get back to this? I want a CCC and then an AC, but I'm not getting that last C at the end. So I want to maybe reconsider my overall strategy. All right, maybe can take and then keep track of the run. See, while there exists a valid move, consume move onto answer, check same value for run of max when k. Okay, let's try this again. Run equals 0. That's true. Turn join as t as a string, and then okay, so for xn, we'll do a scan. If C equals char X, if C in not in M, continue. Okay, otherwise the character is there. Check if it'll run, and then the last value. T dot append the character, and then run plus equals 1. If run equals K, then the last equals character, and then otherwise last equals C. So or last is C and run is K. Then we can continue. Run plus equals 1 if last equals C. Run equals 1 plus run if last equals C, otherwise 1. Okay, so for each value, Z down to A, if the character is not in the map, it's not available, but when do we want to break out? Whenever I cannot take something. If not, okay, then break, and then okay, it's false, and then okay, it's true. Okay, so as long as we find one. So here's our counter characters, our run length, and the last character. All true, okay is false. So for each character, C down to A, if it's not in the map, or it's the same as the last character. Okay, and the run is equal to K. Otherwise, you find one. Append it, increment the run, last to C. Not okay, then we break. Okay, that looks good. Let's see what happens. Uh-oh. Not looking good. Looks like it's gonna TLE infinite loop. Oh, I need to decrement the map. That's why. Okay. Okay equals true. And then m sub c minus equals 1. If not m sub c, then we'll delete it. Last equals this guy. Oops. Z, C, A, Z, that is not right. Why is it not getting Z? Run. What? All right, let's just print out what's going on here. T equals T, M equals M. Last, run. Okay, let's see what happens. Before and after. After, just print another new line. Okay, let's see what happens. Two Z's, four C's, one A. Run is 0, last is -1. Run is 1, last is A. Why am I choosing A as last? What the heck is this? Last. Last is 0. What? Why is it choosing A? 122. What? Before and after. T equals ZCA. Oh, hold on. Okay, I want to break out this first one. Okay, that looks right. ZZ, CCC, AC. So that is correct. ZZ, ZCC, AC. Okay, that is the correct implementation. It's like just print, comment out those prints. Okay, and this one should be BBA, BAA. Looks legit. Okay. Submit it and see what happens. Oh, that's cool. Okay, kind of surprising. Surprise myself sometimes. Obviously, I don't really believe in myself terribly too much, so a lot of work to do. What is that? 18, no, 28 minutes, right? About 28 minutes. So a lot of work to improve here on the coding skills. I came up with basically the strategy here that's complicated and has some edge cases, so that's not that great a solution. This one's much better, right? Let's keep it simple. Delete it when we can, keep track of the run. Okay, let's see how much. I got 25 minutes left. So it's an okay solution. Let's see if we can code it a little bit more quickly and accurately in other languages here. It's good practice. Okay. T is our array, which will turn to a string. Right, so strings are immutable, that's why I want to use an array. Okay, and then want to have a map. New map. Nope. For let's see of S. Set C 1 plus bracket C or 0. Let's count of those. While true. How about do? While okay. Okay equals true. False. False. Or x equals 122. 97. That's for x. X. Character is x dot char from char code. Oops. So log Z. Let me just do this real quick. This is a test. Z down to A inclusive from char code. From char code. X dot from char code. Oh, let's do a string from char code C, right? X, oh, from char code X, oops. Right, okay, Z down to A, that looks legit. Okay, cool. Let's check characters. Okay. If not M dot has C or T dot length. Or wait, hold on. Yeah. And T sub T dot length minus 1. Or it's last, right? Last. Okay, yeah, hold on. Last equal to character and run. It's okay. Check the last run. Let's go 0. Run equals 0. Okay, continue in that case. Otherwise, if we have the C, and we'll take it, T dot push a character onto T. The last character. Run equals 1 plus run if last equals that. Otherwise, it's just 1. Right, you pin it onto yourself if it's the same. Otherwise, it's just 1. And then to break this first time through, and then I also need to, actually, and okay, that's true. And not okay. Okay. While it's okay, continue, like we find one. Doesn't have the character or character is equal to last. Run equals K. Okay. Looks good. Uh-oh. Empty string. T dot push. Character. What? Okay, so okay is false, I suppose, always. Does not have the character. Let's do this. Console.log m. Looks right. What's going on? The right character count. Run. What? Okay, let's just do this. Console log t. Oh, I'm not decrementing that. Okay, that makes sense. So dot set c -1 plus dot get c. If not dot get c, dot delete c. There we go. All right, and that is not correct. C. B, B, A, B, A, A. So, okay, this is not correct. Why am I getting that A before the C though? Have the C. T and then M. Okay, let's see what's going on here. Take the Z, take the Z, take the C. Why are we taking the A? Why are we choosing the A over the C here? The run length, is it incorrect maybe? Last. Oops. Last after that. Okay, let's do this. Push it after we check if it's the same. All right, that looks legit. Okay, that's cool. All right. Delete these print statements. Should be good to go. Yay. Okay, 7:11 to 7:20. 9 minutes. Not too shabby. Could be better, could be worse, I guess. And last character. Yeah, let's see. Push it here. Something like that, right? Okay. Let's do this in C++. That would be our character count. Char last equals that run equals 0. Last run C will be return for each character of the string S. Increment the count of that character in the map. And then while, I'll say do, while okay, equals false, or, yeah, okay, equals false, or auto character C, A, go down to that, and, oops, not okay, okay, so, if not M sub C, or last equals C and, oops, run is okay, continue. Otherwise, we want to say, okay, it's true, say t dot push back, character C, run equals 1 plus run if last equals C, like it's 1, last equals C, and if not M sub, to comment that, then we'll delete it, M dot erase C. Okay. All right, see what happens. That looks legit. Yay. Oops, I didn't tell myself, but I think that was quite a bit faster than the previous implementation. So good practice. 3 plus JavaScript. Ah, J. Okay, and then Kotlin. Okay, this guy. Boom. Those break statements here in Python are pretty ugly. This guy. All right, let's jam in Kotlin. RT equals mutable list of characters. T dot join to string. I need that. Okay. Okay, and the other things I need is var m equals mutable. Wait, hold on. Yeah, var m equals s dot to char array dot grouping by the value itself dot each count. Something like that. Okay, and then var last run pair last is sentinel value that's not A through Z inclusive, and run 0 while true, or while okay. This var okay equals true, okay equals false. Or x in 90 or 122 down to 97 inclusive. The character from ASCII ordinal value, Kotlin character from ASCII ordinal value. What is this? 2 ints. This is like 2 chars. I want the opposite. What is? How to convert char. Let's get one divide to character. ASCII ordinal value to character. Ordinal. What is this? Two char, right? I two char. Okay. Oop, okay. Got two char. Println character. Let's just make sure this is cool. D down to A. Grouping by it. Unresolved reference it. That's that two char rate at grouping by it at each count. Grouping or group by? Is it group by? Receiver type mismatch. Yeah, it should be grouping by, I thought. What the heck? It dot 2int. Is it maybe okay? I don't know. Grouping by two char array. What the heck? Oh. Okay. It two char array dot two list. What a pain in the ass. I think it's something like that. Okay, that's right. Okay, cool. And then we can do println m, right? Print my map. Should be the character counts. Right, see what's cool. Okay. Alrighty. Thanks a lot, Kotlin, for making me change a character array into a list before I can group it. All right, whatever. And actually, I wonder, let's just do this, 2int, probably okay. And then we'll just keep it as x. All right, so as long as it's okay. So if the map does not contain x or last equals x, last and run equals k. We'll continue in that case. Otherwise, okay equals true. And we'll do run equals if last x1 plus run, else just 1. And then last x. M sub x equals m sub x minus 1. If m sub x 0, m dot remove x. Okay, and then break out like that, right? And then we need to push it onto t dot add x dot to char. Resolve reference m dot contains m sub x, no set method providing array access. Oh shoot, okay. be a mutable map. Mutable map of this. To mutable map. Okay, that looks legit. I want to join them to a string. Empty string in between, not comma separated, and that should be good. Yay. Okay, and then Rust. See how much time we got left. I got 3 minutes. Okay, I'm gonna upsolve Rust later on here. Implement me. I don't think anyone wants to watch me hack on Rust because I really don't know what I'm doing. That's good enough for now. That's cool. Okay, so we got 3. 3 out of 4 is not too shabby. I'll take it. A few solutions. Okay, and then once again, I didn't get to Q4, but that's cool and whatever. I'm slowly improving, heading in the right direction, so that's good enough for me. So construct the string t from processing the input string s. Use a map to count each character C in S. Then cherry pick lexicographically maximum. Right. Each lexicographically largest candidate. Until the valid candidates are exhausted. I think that makes sense, right? Construct the string T from processing the input string S. It's the output string, right? Construct the output string T from processing the input string S. Use a map M to count each character C and S, then cherry pick each lexicographically largest candidate until the valid candidates are exhausted. Yeah, I think that makes sense. That's cool enough. Alrighty, I think that's all she wrote. We got 1 minute left. Contest is unrated due to site down issue in China. We'll still reach out to the top 20 winners to give away bonus prizes. Oh, what are these? The bonus prizes? What are these things? Your ranking is finalized. Oh, that's cool. Giving away stuff. Well, I got a long ways to go to get to the top 20. All right, cool. Well, thanks for watching. Catch you next time.